We're going to keep going now with a segment with Bruce Hahn, our Chief Success Officer, on It's Inevitable, Mr. Anderson, an introduction to DEC. So, Bruce.
Thank you, Alex. I don't think I need the... Okay, so we're going to begin this session talking about DEC, D-E-C-C, and I want to invite up some very special panelists. So I want to invite Lisa from Secret Network. Please come on up. I also want to invite Ryan from Sunscreen, and then Shahaf from COTI, and Nico from Arcium. And one of the things, as you see these wonderful people come up, is that they're all blockchain related. Secret Network is an L1. We have COTI who's also doing an L1. And you got to ask yourself, you know, these are L1s. Aren't they supposed to be in competition with each other? And the answer is that we're not. We're actually collaborating. That's the secret. And the session is called It's Inevitable, Mr. Anderson. And I want to find out from you guys, the audience, do you guys not know where that line is from? Anyone not know where that line is from? That's that's great, because I actually asked my team or team members in Partija Foundation, and they're like, so half of them were like, what is that? I don't know where that line is from. And they were like, and I was shocked because I thought everybody knew this. But that's what we're going to talk about. We're going to talk about DEC and why it is inevitable. So maybe just a really quick round of introductions, 1 minute each.
Hi, I'm Lisa Loud. I'm with the Secret Network, and we just ran DCC Day yesterday. DCC is a new movement. It's up and coming. It's overlapping with DPIN. Secret Network is a TEE project. We provide confidential computing using the hardware for encryption, the SGX Secure Enclave for encryption, which is the most practical way to do on-chain encryption today. And I'm the executive director of the Secret Network Foundation, and we're accepting builder applications, so come and build with us.
Great. Hi everyone, my name is Ryan. I work at a company called Sunscreen, where we build fully homomorphic encryption infrastructure and tooling. So what is fully homomorphic encryption? It's a technology that allows you to compute over encrypted data without decrypting it first, which is quite exciting because it allows you to preserve user privacy and these types of things. But one of the challenges of FHE is that it's a little bit difficult to use if you don't have a math background. So we build a lot of tooling, such as a Rust compiler that allows you to write kind of regular programs and convert those into FHE variants to be able to add privacy to any of your applications.
That's some engineering talk there. That's good stuff.
Yeah, completing the trinity of TE, FHE. The missing one is MPC, and that's what we're working on at Arcium. We're building tooling with which you can compute directly on encrypted data as well. However, instead of using FHE, we use MPC for that.
Hey everybody, I'm Shahaf. I'm the founder and CEO of COTI. COTI is building a privacy-centric Ethereum Layer 2. We've been around forever, since 2017. So we do two things differently. One is that we use innovative technology called gobbling circuits. So one must say now TEE, FHE, MPC, and GC, gobbling circuits. It's the first time it's being used on blockchain. Essentially, it allows you to do things kind of like fully homomorphic encryption. So use encrypted data without deciphering it. But with much greater scalability. So we've just launched testnet last night successfully, and we've benchmarked like amazing scalability data. So everybody's more than welcome to start building on top of COTI. The other thing is that we're building it on top of our current network. So we already have a token out, ranging in about $200 million, traded everywhere. Not a financial advice, but so that's, I guess, the second thing. So,
well, a big congratulations to COTI, for sure. Congratulations.
Thank you.
So the session is called It's Inevitable, Mr. Anderson. And so one of the questions that I wanted to ask you guys, we talk a lot about confidential computing, and we talk about inevitability. Lisa, maybe you could start us off with why is confidential computing an inevitability in Web3?
It's funny because our CEO of Secret Labs, who's right here in the front, read an article recently about how it's inevitable. The reason that you can't, it's kind of like a matrix, really. We're all going along in this mass illusion that blockchain is good, and blockchain brings wonderful things to us, brings decentralization of power, of control, of accessibility, and yet it also brings radical transparency. Radical transparency is great in relationships, but when you're talking about banking transactions, it's not so great. I had an experience when I got here. I used the Grab app to get a rideshare from the airport. Tried to use my Visa, tried to use my MasterCard, didn't work. Tried to use my PayPal, that didn't work. I tried to get Pay Now, that didn't work. Finally, it said you can pay with ETH. I was desperate at that point. I'm like, okay, I'm gonna pay with ETH. But I wasn't too comfortable with it because now the Grab app has my ETH address, right? And I used a separate one because I am concerned about this. But radical transparency in blockchain is not a great thing. What if your driver can look up your ETH address and then figure out how much money you have and which hotel you're staying at? And that could lead to a bad combination of circumstances. So as we're seeing blockchain evolve and industry starting to adopt it, the first thing they run into is, wait a second, where am I going to keep my IP? Where am I going to keep my customer data? Does that have to go off-chain? Well, ideally, no. Ideally, it can all go on-chain, but it needs to be encrypted, and that is why DCC is inevitable.
Absolutely agree. And then I think I just want to add, how many of you guys do or want to get paid in cryptocurrency? If you guys want to get paid in cryptocurrency and your employers are paying you in cryptocurrency, they have your address and they know what it is that you do with it. Now, in the real world, I don't think that's a possibility, right? And so I think that's one of the things that blockchains miss.
And your coworkers know what you got paid.
Oh yeah, your coworkers know. You know, that's. Oof.
Yeah, I would agree with everything that Lisa said. I think also maybe what's kind of an interesting idea is that Web 2 originally started off as a very transparent system, and it turned out that people essentially were being able to be fingerprinted, and there were a lot of kind of information that people didn't want to have leaked, such as your salary and these types of things. And so eventually the web did move over, Web 2 did move over to a encrypted form through HTTPS. And that's great because that allows us to have private banking and these types of things, private paychecks, and everything like that. So Web 3 is a very exciting technology, adds also some neat decentralization. At the moment it's extremely transparent. So adding that type of privacy that kind of maybe investors or just even regular folks would expect, such as their banking details are private, is kind of key to making Web3 successful in the large.
You're really talking about like a evolution, the maturity of an evolving technology.
Yeah, absolutely. It's Web3 is great at the moment. It's adding new and evolving into an even better technology than it is at the moment.
Yeah, I mean, definitely agree with the previous points. Just from my personal experience, whenever I meet someone who's not in crypto and I tell them what I work on, usually the first reaction, or oftentimes, is, wait a minute, I thought Web3 was already private by default. Like if I look in the block explorer, all I see is these hexadecimal symbols and whatnot. And then usually when I tell people, no, it's actually not. Everything's fully publicly visible. You can just decipher that into plain text very easily. I don't think I've ever had the reaction where someone was like, oh, that's awesome. I wish the regular web was like that, where everyone could see who I send money to. So like from that aspect, obviously, as was previously said already. But another aspect I think is quite important to mention here as well, is that personally, at least for myself, I think for Web3, one of the biggest use cases is, finances, of course. And there, if you kind of look at, how finance, like at least DeFi behaves for the most part today, you have huge problems with MEV and front running and all these problems that you don't have, to the same extent in traditional markets. On one hand, for regulatory reasons, of course, but on the other hand, also because there you have the option at least to choose which parts you make public and which parts you make private, and through that can offer better performance in general. So I think if we really want to, onboard a large amount of traditional finance players and not have most of that volume going through Binance or Coinbase or whatever, DCC really isn't an option, but mandatory.
Yeah, we're talking about now regulatory compliance, the maturity of the industry itself from a compliance perspective.
Yeah, but also from a just financial perspective. Like the reason that, if you buy more than $1 million on any exchange pretty much for almost any pair, you get more than 1% slippage, which is insane, is for the most part because mempools aren't encrypted and on-chain state isn't encrypted either.
That's a great point.
So I don't want to echo what everybody said because I fully agree. Other than radical transparency is good for relationship. It's almost ruined my life. But I think it goes deeper than that. Because it's pretty clear that average Joe would not use Web3 components if he knew what it meant about putting everything on a public blockchain, and no major business will go on chain if their data is fully there for everybody. And if people don't get that and how inevitable that is, they can't be helped, right? There's no point in educating it because that's the reality and it's coming. But I think it goes deeper because if we want to live in a future where it's not about 5 major companies controlling the internet, right? It's not all Web2 infrastructure, you're funneled through 4 apps that collect all your data and everything. If we want a different future, then this part of the infrastructure must be built. If we're not going to do that, then we're not going to have a Web3 future, for sure.
Yeah, this is really the vision of what Web3 was really about. And I think what you're saying is that without that level of privacy, it cannot be reached.
No, it's inevitable.
Perfect, thank you. Thank you so much. So first of all, these questions are new to them. They did not get these questions pre-session. So these are like real, on-the-spot answers, first of all. So that's number one. So to make it fair, I'm going to go back to you, Shahaf, and then ask you my second question, which again, you don't know what it is. So when most people think about privacy in the Web3 sphere, they think of things like Monero and Zcash. What's the difference between them and our technology?
Yes, so it goes to the difference between confidential computing or confidential transactions, if you may, to anonymity. So what we do is not about private tokens. We do not try to obscure the fact that a transaction actually happened or between what addresses this transaction happened. What we are trying to do is actually mimic the convention that if I send you something, I don't want the entire world to know what that is. So confidential computing actually discusses the metadata of the transaction or maybe the payload of it. So what are we sending? What are the amounts? What are the balances? Everything that we actually want to have private, even if we're not criminals, because it's normal. So this is confidential computing. Anonymity means that nobody knows what actually happened. Nobody can backtrace it. And while there are actually relevant and goodwill use cases for that as well, it obviously attracts criminality. And this is why regulators will not have that.
Yeah, that makes sense. Maybe Nico, from your perspective, from a technical perspective, maybe you could try to explain the difference between what confidential computing and privacy-enhanced technologies are versus these privacy coins.
Yeah, for sure. I think what's important to note here as well is that, generally speaking, I don't think the inventors of Zcash or Monero, didn't think of this. They didn't invent coins where you purely have transactional privacy in the sense that you hide the amount and the sender, but you can't really do generic compute on it. The reason they didn't do this is not because they're stupid or something, but just because at the time when it was invented, just cryptography, the cryptography for it was in its early stages, as it still is today, but it was so early that it wasn't really feasible to implement at the time confidential compute as we're building now. And I think that's where the main difference comes from, basically, that instead of saying, okay, we only hide for specific transfers, which is decently useful, we actually allow people to build, generally speaking, any program that they want, whether that be, an exchange, some, I don't know, NFT thing, some gaming thing, whatever it may be. And I think that's very inspirational to see the amount of projects building in this space, just because it shows that as sort of transparent blockchains have evolved from the initial Bitcoin, which was the same idea of just transfers, but not much more than that, to most blockchains today being smart contract platforms. So has privacy tech in the form of going from just transfer privacy to general computational privacy, allowing for any smart contract to be built in an encrypted manner.
Yeah, thanks. That makes sense. I'm going to try to change the question from a technical question to more of a philosophical one, and this is going to be a challenging one.
Okay.
All right?
Sounds
okay.
Good.
So I think Shahaf was talking about the fact that, things like Monero and Zcash, they're like anonymous, right? And our technology is really about privacy. So what are your thoughts about the differences between what anonymous is and what privacy is?
Yeah, that's a great question. So Zcash and Monero offer private transaction, these types of things, or anonymous transactions. A lot of the DCC technologies, FHE, MPC, TEs, garbled circuits, essentially allow you to operate over encrypted state. And that ability allows you to build a lot more than just the actual transaction. So one of the examples that Sunscreen has is that we're able to essentially provide sealed bid auctions where you hide all of the bids except for the person who wins. So there's kind of an addition there. In terms of the philosophical component, what I would say is that a lot of the cryptography technologies can be compliance friendly. So essentially, Zcash and Monero might be designed in a way that there is absolutely no way in which you can back out of its particular transaction, at least with FHE and all these other technologies. You could build systems such that they are regulatory compliant, where you could say have private transactions, you could send transactions to other people, but you could have some mechanism, maybe a threshold distributed trust mechanism that allows you to decrypt in the case that you need to fulfill some sort of regulatory compliance. So in the philosophical sense, I would say that the technologies for DCC enable us to kind of match a sweet spot in terms of matching what the governments and potentially institutional investors and what other people might expect out of their systems.
Yeah, I think if I can put that simply, it's like Zcash Monero is not compliant, but DEC is.
Yes, precisely. Yeah, you can make it compliant.
Perfect, thanks. Lisa?
I just want to debate that point a little bit, because while I was of the same mind for a long time that we could provide decryption for compliant reasons if governments required it, and I still am on the fence about it. I met with Commissioner Hester Peirce of the U.S. SEC Commission, and I said that to her, and she said, I'm really worried that the crypto industry is going too far from its roots, and you're trying to build backdoors into everything, which can then be misused, abused by corrupted individuals or corrupted governments. And so I don't know what the answer is, but I do think we have to question whether it makes sense to build backdoors that can be used in the event it's needed.
Yeah, that's a great point. I should say that it's not necessarily a backdoor. So maybe in the sense that Ethereum or any of these blockchains have essentially distributed trusts where you have to have a majority or honest majority actually participating in order to secure the network. You could still have that. So you wouldn't necessarily have just the government, the law enforcement has a key to unlock this. That wouldn't be true. You would still have distributed trust. It's just distributed trust in a way that allows for compliance with regulation. But I do agree that it is a completely nuanced situation.
But I would say the difference in general is just that anonymity is much more sensational than confidential computing. It's harder to explain confidential computing.
Thanks. I love the debate. That's what I was hoping for. So thank you guys. So my take on it really is that privacy, the difference between privacy and anonymity is that one really enables trust between two relationships or more, and one actually does not enable trust. So if you're anonymous to somebody, it's very difficult to begin to trust somebody. But privacy is actually something that enables you to build trust, trust between two or more entities together. So, it's $5 every time you use it. But yeah, that's what I think about the difference between anonymity and privacy.
Did you see the questions beforehand? Because that sounds like you prepped a little.
No, maybe. Okay, perfect. So I want to now jump back to Lisa now. When a lot of people think about privacy these days, they think about zero knowledge proof. But there's no zero knowledge proof team here. We all do something a little bit different. And so I wanted to see if you could talk about your specific technology, each of you guys, your specific technology, because I think one of the key things for the audience is that they need to, we have to explain to them that there's a reason why we collaborate. It's because every single one of our technology does something a little bit differently, and it has different use cases. So maybe let's explore that a little bit. Maybe you could, Lisa, begin.
Yeah, so ZK has a lot of public mindshare, but it does have limitations. There's only certain things you can do with zero knowledge proofs. You can get an answer, a yes or no answer back. But if you want to do, like you were saying, anything with programmability, anything that depends on conditions or that it has some computations involved, zero knowledge is not the solution for you, because all it will do is this very simple I think it's only two-party, which is why MPC is different. Two parties can verify something. So it's trustless. It's a way to verify, are you a member of this set or are you not? But it doesn't do all of these things that we're talking about with confidential computing that have been raised already. And then in terms of the different technologies, I said at the beginning of my intro that TEE is the most practical method of doing confidential computing today, and that's because, well, the other thing with ZK is it's very computationally intense for what it does. TEE has the advantage of being the least computationally intense method of doing confidential computing right now, and that's because we have a shortcut. We use the Intel Secure Enclave, which allows us to do a lot of stuff inside the enclave and reduces the math required for like an FHE solution. Things don't have to be calculated on the spot. They can be shortcut, stashed in the secure enclave, and then you can do operations on them without revealing them. So it's basically a shortcut. However, the downsides of TEE are that it's not as purist as FHE. FHE is like classical ballet, and TEE is the Macarena, which anyone can do. So what I'd say is that, and then the other thing is quantum resistance. I don't think TEE is ever going to be as quantum resistant as FHE. But for today, if you're building, TEE is the way to go.
So Lisa, first of all, thank you so much, because I was going to actually ask the pros and cons of each of our technologies. So I didn't even have to prompt you. Thank you so much for providing that. And I would ask that of all the panelists, the pros and cons of each of your technologies.
Yeah, so as mentioned by Lisa, there's FHE provides the ability to operate over encrypted data, and it operates really within a space of, there's a lot of different ways to tackle this problem. So TEs are very exciting because they are very performant. They have a little bit different security profile than FHE. So FHE, as you mentioned, I really liked that ballet example, is kind of is cryptographically secure even outside of a secure enclave. So it does come with some performance penalties. It's not quite as performant, but it does increase the security threshold that you necessarily want. So one would potentially say that FHE is, say, compute bound. There's also MPC, which is maybe more communication bound. So you can kind of choose where you want to be within this space in order to figure out precisely what technology fits. Back to the kind of original point with ZKs, one thing I do want to mention is that a lot of these technologies can be mixed and matched. And specifically, one thing that's kind of exciting about using DCC and specifically FHE is you can combine it with things like zero knowledge proofs. So one of the things that Sunscreen's worked on is that we have a zero knowledge proof compiler as well. And they actually, the fully homomorphic encryption compiler and the zero knowledge proof compiler can link together. So there are some applications where, say, for the private auction I was mentioning, you can actually use crypto economic security in order to ensure that an application works. But if you want to say, like, a transfer from one person to another is valid, the person has enough of a balance in order to perform a transfer, you can add zero knowledge proofs on top of your FHE program in order to be able to show that not only provide this, but say that the person can actually do this transaction, not just compute it.
I think that's a great point, and I think that's one of the reasons why we're all in this kind of together, because not only are we looking to promote the need for privacy or confidential computing technology in the blockchain, because we all kind of do something a little bit slightly different, we can actually collaborate with each other. So we could layer on MPC on top of TEE, or with homomorphic encryption and MPC to do different things. So I think that's a great point.
Yeah, I don't think we're necessarily competitors. We're exploring a landscape together. Yeah.
Perfectly put.
Yeah, so one more thing about what makes it different to ZK. Like, a way that I always like to think about it is that the main idea of ZK is that you say, you have some secret data that an individual knows, and then basically that individual can generate a proof where they say, okay, I reveal a certain part of my data or a certain property of my data, but I don't actually reveal my input data. And this sounds pretty good, but it doesn't allow for a shared state. Essentially, if we have some piece of state that lives on chain, for example, like an order book, and there's one person that submits one order, another person that submits another order, there isn't really a way that you could generate a zero-knowledge proof over that easily, just because there isn't any single person that would know what every single order looks like if it's secret data. And that's basically where TE, FHE, and MPC comes in essentially allowing you to work directly with such a shared state in a private manner. And yeah, we already heard about TE and FHE. And I think MPC sort of comes in at, like, obviously I'm biased since I'm working with it, but at a nice middle ground between the two, in the sense that it's, similar to FHE, is cryptographically pure, as Lisa put it, or a little bit more cynical, I guess you could say that unlike TEs, you can prove that it's actually secure based on mathematics rather than having to trust Intel or some hardware producer that it's actually secure. And on the flip side, it also has a nice benefit that, at least as of today, it's significantly more performant than FHE is. Of course, that might change with hardware, but as today is the case, I think MPC is the best solution to go for if you want to do DCC.
So gobbling circuits have been around since the 90s. It was invented it's cryptography that was invented to solve a problem. It's a bit of a douchebag problem, but say there's a neighborhood and everybody want to know who's the richest guy in the neighborhood, right? But they don't want to tell everybody how much they're worth. They just want to know who's the richest, right? It's a terrible neighborhood. But with gobbling circuits, you can actually have everybody write this on a piece of paper. But it's a code. Nobody can actually understand what's written on the paper. Put it in a magical box, and we'll just tell you who's the richest guy. So the inputs are private, and the function that calculates the input is private as well. So that's the idea behind gobbling circuits. And it's been around since the 90s. So why haven't we seen it on blockchain yet? The reasoning is that the performance was horrible, until a certain invention made by Dr. Avishai Nai and Dr. Meital Levi, cryptographers, that built a company called Soda Labs, and they actually made it very, very useful. So they've optimized it a bit differently. GC is cryptographically pure, but it is a subset of MPC. So communication is usually the issue, but they've managed to limit the rounds of communication needed. So that gets us to allowing the functionality of FHE, because you can put everything in a circuit, but without the need to sacrifice performance, because it's not computationally heavy. And it's also light. The proofs are very light. So yes, we optimize for communication. I mean, this is because we believe communication is cheaper and almost free right now. And GC is the new kid on the block, right? Everybody's talking about FHE, TE, MPC. So we need to prove ourselves. But I think with the testnet that is out there right now and the benchmarks that are actually been captured, I think we'll do well.
Thank you so much. I know we are running out of time. I think we are actually out of time. So I want to thank the panelists to join us to talk about DEC. This is what DEC is really all about. It's about bringing the ability to trust in blockchain through the use of confidential computing. So thank you very much, guys. Insightful conversation, and I'll be looking forward to collaborating with you guys even further. Thank you.
Thank you.
Wonderful. Thank you very much to the panelists. We are going to have another